So when we face some customers who own some like factory, hospital, or hotels who require the solar systems, they always ask like how I can build a solar system for my entity. So today I'm going to introduce how we make the solar system evaluation for commercial and industrial. Okay. So the first question our salesman should ask about to the customers is, what's your maximum load? For many customers, for example, they own the factories, they have the inductive load, okay? When we ask about the maximum load, we have to pay attention to their inductive load. Inductive load. For example, I own a factory of injection factory, plastic injection factory. And my maximum load of my factory is 800 kilowatt. But in my factory, I have a lot of devices with motors or compressors. You know, these two components are all for the inductive load. Motors and compressors, okay? So when they are using the inductive load, their claim maximum load is 800 kilowatt. But with motors, maybe 3 to 5 times. At the compressors, maybe 5 to 7 times of what they claim about their maximum load. So in this case, it's around 4 megawatt. In this case, around 5.6 megawatt. How will you deal with the applications with inductive load? We have to add VFD, Verified Frequency Device, to their motors or compressors to smooth their immediate starting currency. Starting currency. So, for example, in this maximum load, our value is 800 kilowatt. For example, in this case, our maximum load is 800 kilowatt. We assume when the customer runs the machines, their maximum load will be like this. However, if it is with the inductive load, like motors or compressors, their running diagrams will be like this. So you see, we call this the peak, or the starting power of inductive load. And with VFD, we call this device Verified Frequency Device. It can eliminate this starting power inductive load to smooth the starting point of the machines. So with VFD, it will be run like this. So as for the maximum load, we use VFD to eliminate the starting point of the motors or compressors, which is inductive load, okay? And if we want to design the system based on this, the maximum load decide our inverter or PCS size. So Laura, in our case, the maximum load, if the customer tells us, is 800 kilowatt. What's the size of the inverter or PCS we should design for this system? Yeah, around 800 kilowatt, because the maximum load, the claim is 800 kilowatt.
Just around is fine.
Yeah, just smaller than this load. Bigger than this load is enough for 800 kilowatt. So the first question we ask about the customer is about their maximum load, okay? the customer tell us 800 kilowatt, and it's without motors or compressors, those kind of inductive load. So we can design the system like inverter or PCS size as 800 kilowatt. So we have confirmed the first inverter or PCS 800 kilowatt. Okay? And after this question, what we need to ask secondly is hours of backup. So after we confirm the maximum load of our system, we need to ask them the second question: how many hours of the backup we need the system to support the whole factory running? For example, in our case, the customer reply, I need 2 hours backup. So what's the system size we should design for the battery?
1,600.
Yes. 800 kilowatts by 2 hours, 1.6 megawatt hour. This is the required size of the system. However, in our systems, our DOD refers to depth of discharge. Normally, it's 80%. That's a standard system DOD, okay? So in the DOD 80% condition, what's the battery capacity we should design for this? 1.6 megawatt hour divide 0.8. How much is it? 2 point what? 2.0 megawatt hour. So the real battery capacity will be around 2 megawatt hour with a DOD of 80%, which can give the charge or discharge 1.6 megawatt hour to fulfill the customer's 2 hours backup. Okay, so we have got the second parameter, battery, around 2 megawatt hour. Okay. And the third question. Actually, this question we don't need to ask the customer. We can check ChatGPT how many hours of the sunshine factor. For example, in our case, it's in Africa. So the data for sunshine factor is around 5. Which means they have fully available 5 hours, good sunshine condition. Sometimes the customer doesn't really know, like how many hours backup. So you should ask them actually it's a false question. What's the running time of your factory? For example, in some factory, from 9 a.m. till 9 p.m. Okay, 9 a.m. till 9 p.m. And when we check their country, the sunset time around 5 p.m. So we can divide into 9 a.m. till 5 p.m. and from 5 p.m. till 9 p.m. Here we have 8 hours. 8 hours running. By here we have another 4 hours running. Okay, so during this period of time, if we have enough PV, enough solar, the solar can go to the load directly without passing through the battery, and the remaining power can be stored in the battery. But at this period of time, basically there's no sunshine, which means we have totally rely on our battery backup. Okay, so it's related to the hours of the backup, as here you can see. What customer claim is 2 hours, for example, but what we calculate is 4 hours. In this case, we have to tell our customer, if you need the full load, for example, 800 kilowatt, to run from 5 p.m. till 9 p.m., 4 hours, so we have to double the size of our battery backup, which is not 2 megawatt hour, okay? We have to make 4 hours backup, which is 4 megawatt hour. Okay, so here you can see we have 2 periods of time which require the solar system power, okay? From 9 a.m. till 5 p.m., while there is sunshine. Sun available. Okay? And from 5 p.m. till 9 p.m., there is no sunshine. No sun. So we will design the system like this. From 9 a.m. till 5 p.m., basically maybe earlier, like from 8 or 6 a.m. till 5 p.m. The solar power will go to the first priority, to the load. Second priority, to the battery. Okay? So the solar will go to the load first, remaining power stores in the battery. That's from 6 a.m. till 5 p.m. Because the solar may start at 6 a.m. Even though there's no load, the solar power will be stored in the battery. You can understand this point, right? Yes. Okay. But from 5 p.m., the solar will be shut down. So we will use the battery to go to the load. Okay. Like this. So according to the calculation, what's the battery required is 4 megawatt hour to be charged, 4 megawatt hour, okay? And for the load, we have around 9 a.m. till 5 p.m., 8 hours, which require 800 kilowatt hour. So it's around 6.4 megawatt hour. How much energy we need in total? Yeah, 10.4 megawatt hour. How we can generate 10.4 megawatt hour? Solar.
Yes.
Yes. So we have available 5 hours sun, right? According to our calculation, is around 10.4 megawatt hour divided by 5 hours available sun charging, which is around 2.08 megawatt. So here we can decide the MPPT size, which is around 2.08 megawatt. After all this calculation, so basically we can form a complete solution for the customer. It's around 1 megawatt system by 4 megawatt hour ESS with 2.08 megawatt MPPT. Okay. And the solar size should be around PV 2.08 megawatt divided by 0.8. So this is a common factor. For example, in Africa, you can use 0.8. In China, you can use 0.6 because the solar panel will have some efficiency, like 80% or 60%, according to the different environment. In Africa, we can use 0.8. So we will be need, how much is it? 2.08 divided 0.8.
About 3.
About 3, yeah. Let's make it like 3. Okay. 3 megawatt. 3 megawatt PV. So you will tell customer, you will need a 3 megawatt solar, okay, with our all-in-one ESS, 4 megawatt hour of 1 megawatt PCS with the 2.08 megawatt MPPT. But we don't have such device. Normally this 2 megawatt, we call it a 0.5 P system. So you will be sending to the customer 4 megawatt hour ESS 0.5 P, 2 megawatt with 2 megawatt MPPT with 3 megawatt PV system. So this is a complete C&I solar system evaluation. From the starting point, you remember what is the starting point? The first question.
Starting point is from the time.
No, it's a maximum load.
Maximum load.
Yes, from the maximum load. So let's conclude how we evaluate. The first question we ask is about your maximum load.
Yes.
Your PCS or inverter cannot be smaller than your maximum load. And when you consider your maximum load, you have to consider if there is inductive load or it's inductive load with VFD or not. If it's not VFD, you have to suggest the customer to install the VFD first to avoid the starting currency. Okay? Why we need to avoid the starting currency? Because in this case, even though the maximum power is 800 kilowatt, but with inductive load, it may reach 5 megawatt, 6 megawatt, which is more than our PCS size. So it will occur the over-currency protection for the whole system, and the whole system will shut down due to this. So you have to use the VFD.
So I need to confirm if they have compressor first.
Compressor or motor?
Or motor.
Yes.
If they have, I need to get confirmed if they have VFD.
Yes.
And if not, we need to provide them with.
Yes, we can provide them the VFD component, okay? And after this first question, you have to ask about their backup hours. But according to our experience, the customer always not telling the real situation. They are a bit confused. For example, in our case, the customer telling, okay, they need 2 hours backup only. However, in the real case, when we ask them about more questions, like what's their running hours of their working time, okay? So it's from 9 a.m. till 9 p.m. So they need around 4 hours backup, which is more than what they consume, like a 2 hours backup. So we have to double the size, 4 hours, according to 800 maximum load by 4 hours backup, which is around 4 megawatt hour. Okay, so we can confirm the battery size. And thirdly, we check their sunshine factor of their country, which is around 5 hours. And according to all the energy required for the whole system running, fully ran, we got this MPPT size, 2 megawatt. So basically, that's how we evaluate a commercial and industrial case for the solar system. Okay, is it clear for you? So there's a task for you after this lecture, okay? So you have to design a questionnaire, a common questionnaire for customers to fill it, okay? So whenever there's a case like the customer tell you, okay, Luna, I have a factory, I have a hotel, I have a hospital, you just throw them the questionnaire, ask them to fulfill it, then you design the system for them, okay? Okay.